Hello everyone, this is Mr. McMillan and I'm here with another instructional video, this time beginning our unit on basic properties of triangles. Okay, so we're going to start out today talking about classifying triangles as well as the triangle sum theorem. Tomorrow we will be discussing the triangle inequality theorem and what we can do with that. So, for this lesson, we're going to be discussing different types of triangles and their various properties. We'll discuss the types of triangles, the triangle sum theorem, and the triangle inequality theorem. This will be tomorrow. We probably won't have time to do it today. So, basic properties of a triangle. A triangle is a figure formed by three segments called sides. Okay, so the segments are the sides, and these three segments join three non-collinear points, which are called vertices. Okay, so a triangle has three sides and three vertices. The three vertices are the 3 points that the sides connect. A triangle with vertices A, B, and C is written as, now we literally use the triangle symbol, a triangle symbol, and then A, B, C. You could also write this in any order of these three. You could write triangle VAC, triangle CBA, so on and so forth. Okay? So if you see this in a problem, it just means it's talking about a triangle that has vertices A, B, and C. All right, our triangle sum theorem. The sum of the measures of the interior, remember interior means inside, angles of a triangle is 180 degrees. Okay. So if we're talking about this triangle over here, right, symbolically, what we're saying is that these three angles, the measures of them added together equals 180. So in triangle ABC, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Okay. So these have to equal, when they add up together, they have to equal exactly 180. They can't be 179, 181, anything like that. They have to be exactly 180 in order to be angles of a triangle. So looking at this diagram, what are our vertices? Well, the vertices are the 3 points here, and we have them labeled as A, B, and C. So A, B, and C are our vertices. Then our sides of the triangle, well, the sides are any one of the segments that connect two of the vertices together. So we have AB here. So we have AB. Remember, we're naming a line segment. Then we have BC. And then AC. And then our angles, the way we label our angles when you just have a triangle by itself is we label it using the name of the vertices. So the angles should be the exact same as the vertices, just with an angle symbol in front of it. So angle A, angle B, and angle C. Okay. Now this will be important. The reason we're doing this is because I want you to be able to identify certain aspects of triangles, which will be helpful in our next few units. So, triangle sum theorem. Find the value of the indicated angle or the value of x. So, some of these will have a question mark, and that's the one they want you to find, and some of them will have you solve for an equation. Okay, so we're going to do the first 5 together, and then what I want you to do is do the last 4 on your own, and then check your answers. Okay, so first 5 together. So number 1, we have a triangle here, and we want to find this angle here. I'm going to put an X in it just to make it a little bit easier. And our other 2 angles are 87 degrees and 45 degrees. Well, we know that these must sum up to 180. So in order to find x, we know that x has to equal 180 minus the other two angles. Okay. And so 180 minus 87 minus 45 will end up giving us 48 degrees. And you can check that. You can take these three angles again, add them together, and see if they give you 180. 48 plus 45 is 93, plus 87 is 180, so we did that correctly. All right, number 2, we're given the angle measures of 20 degrees and 135 degrees, and we want to find this angle x. Again, triangle sum theorem states that the sum of the measures of the interior angles of a triangle is 180 degrees. So we take x, and that's equal to 180 minus 135 minus 20. And if we work that out, we end up getting x equals 25 degrees. Number three. Now this one's a little bit different. You need to make sure you're paying attention to what the problem is showing you in these images. So if we look here, we see a 25-degree angle. Do you see another angle that is indicated on the diagram? Well, you should see this corner box here or box in the corner. Remember, that signifies a right angle, and a right angle has a 90-degree angle measure. So if we want to find x here, we take 180, subtract 90, and subtract 25. So that gives us that x has to equal 65 degrees. All right, number 4. Number 4, this time it looks like we're going to be solving for x because we have an expression here. Our other two angles are 70 degrees. Well, remember, the three angles have to add up to 180 degrees. So we're going to add all three of these together and set them equal to 180. So 4x plus 4 plus 70 plus 70 equals 180. 4 plus 70 plus 70 gives us 144. Subtract 144 from both sides, and you get 4x equals 36. Divide both sides by 4, and you get that x equals 9. If you want to check that, you can plug x in here. So 4 times 9 is 36, plus 4 is 40. Then you can add them together and see if they do indeed give you 180. So 40 plus 70 is 110. 110 plus 70 is 180, so we did that correctly. And then number 5, the last one we're going to do together. We have a 5x here, so we're solving for x. We have a 50-degree angle here, and in the corner here we have a 90-degree angle that's indicated by that box there in the corner. So we add these three together, and we get 5x plus 50 plus 90 equals 180. 50 plus 90 gives us 140. Subtract 140 from both sides, and we get 5x equals 40. Divide both sides by 5, and we get x equal 8. Again, if you want to plug that in, you can. You'll get 40 for this degree angle measure. 40 plus 50 plus 90 does equal 180. So what I want you to do now, I want you to pause the video, and I want you to try this number 6, 7, 8, and 9 on your own. Okay. Then once you're done with them, unpause the video and watch to see if you got the correct answer. All right, guys, let's do number 6. So number 6, we have 22 degrees and 137, and we want to find our missing angle here. So x equals 180 minus 22 minus 137. And if we solve that out, we get x is 21 degrees. Number 7, we want to find this missing angle here. We're going to put an X there. We see that we have a 90-degree angle here because of the right angle measure marking, and then a 40-degree angle. So we know that X has to equal 180 minus 90 minus 40. And if we end up working that out, we end up getting X is 50 degrees. Number 8, we're going to be solving for X here. The triangle sum theorem states that the sum of the interior angles of a triangle add up to 180 degrees. So we're going to take all 3 of these angles and add them together. So 16 plus 4X plus 40 plus 80 is equal to 180. 4X drops down. 16 plus 40 plus 80 is equal to 136. Subtract 136 from both sides. We get 4X equals 44. Divide both sides by 4, and we get that X is equal to 11. Number 9. Number 9, we're solving for X again. We have a 25-degree angle here. We have a 90-degree angle here. And 14X minus 5 is our other angle here. So we need to add all these together and set them equal to 180, then solve for X. So 14X minus 5 plus 90 plus 25 equals 180. Negative 5 plus 90 plus 25 gives us 110. 14X plus 110 is equal to 180. Subtract 110 from both sides, and we get 14X equals 70. Divide both sides by 14, and we get that X is equal to 5. Okay, so that's the triangle sum theorem in a nutshell. Add all the angles together, they should be equal to 180. Okay, so let's flip on over to classifying triangles. So triangles can be classified based on their sides and their angles. Triangle classifications based on sides are either scalene, isosceles, or equilateral, and based on angles are either acute, obtuse, or right. Note, any triangle can be classified with multiple descriptors. For example, we could say they are acute scalene, obtuse isosceles, etc. So let's complete the chart below to see how we can classify the angles, and note the markings in the example diagrams for each type of triangle. Okay, so the first one we're going to be talking about is an acute triangle, and the way you can tell an acute triangle is that all 3 angles are, well, they have to be acute. And if you remember acute angles, that means every angle has a measure that is less than 90 degrees. Okay, and an acute triangle or acute can be scalene or isosceles. Okay, and we'll talk about what scalene and isosceles means. So if you look at this diagram here over on the right side, we can see visually that all of the angles, angles A, angle B, and angle C, are all acute angles. Okay. So acute triangle, you're looking for all acute angles. Next up, a right triangle. Well, you guys should know that a right triangle has exactly one right angle. And remember that a right angle is a 90-degree angle. The other 2 angles are going to be acute. Okay, you cannot have a triangle with 2 right angles. You cannot have a triangle with a right angle and an obtuse angle. If you have a right angle, the others have to be acute. Okay, so we can see in our diagram here, if we look at our marking in the bottom left corner, we see that angle Y is a right angle So that's why triangle XYZ is a right triangle. Next up, an obtuse triangle. As the name implies, an obtuse triangle has exactly one obtuse angle. So that means its measure is greater than 90 degrees. And just like right triangles, if you have an obtuse triangle, the other two angles must be acute. Okay, so if we look at our diagram here, we can see that K and L are both acute, and M is our obtuse angle. That's what makes triangle KML an obtuse triangle. All right, next up, scalene triangle. Now, a scalene triangle is a triangle that has no congruent sides. That means that none of the sides are the same as any of the others. So every side has a different measure. No congruent sides for a scalene triangle. All angles also must have different measures. So even if you have, let's say you were given one that did not have the sides labeled on it. If all your angles are different, that means that it has to be scalene as well. Okay, and you can have acute scalene, right scalene, or obtuse scalene angles. Okay, if you look on the diagram here, W, F, and P, notice that none of these angles have any markings with them, and none of the sides have any shared markings either. So there are no congruency markings for any sides or angles. Next up is our isosceles triangle. An isosceles triangle has at least two congruent sides. So two sides have to be the same. And if two sides are the same, then that means that at least two angles must be the same. And these angles and sides are opposite one another. Okay, they're opposite one another. So let me show you what I'm talking about here. If you look at this diagram, you see these tick marks here, right? That means that CD is congruent to CE. Okay, but you also see these semicircles on angles D and E. That means that angle E is congruent to angle D. And what I was talking about with the opposite sides and opposite angles here, if you draw going from D and draw an arrow going straight out, the opposite side to D is CE. And you'll also see that E is opposite side CD. Okay. That will be important for when we start talking about the triangle inequality theorem tomorrow. Next up, equilateral triangles. An equilateral triangle, well, equilateral literally means equal lengths triangle. So that means that it has three congruent sides and three congruent angles. And an equilateral triangle is sometimes also known as an equiangular triangle, but we don't use that too much. Okay. So if we look at our diagram here, we have triangle RST, and you'll notice that all three of the angles have the exact same mark. So that means that angle R is congruent to angle S, which is congruent to angle T. But you'll also notice that the sides have the exact same markings. So that means that line segment RS is congruent to line segment ST, which is congruent to line segment RT. And if you're really curious about it, well, you know these have to be equal. You know these have to be equal. Well, the sum of the triangles, or sum of the angles in a triangle, is 180 degrees. So if you have three angles that must be the exact same, you take 180, divide it by 3, and that means you have 60-degree angle measures always for an equilateral triangle. Okay, all three have to be 60 degrees. So let's look at some examples for classifying this. Number 1, well, all these want us to classify the following triangles by their sides and their angles. So we need to look and see if there are any markings present that would help us. Okay, so on number 1, we see that there are no congruency markings on any of the angles or any of the sides, no tick marks or semicircles. However, we do see that there is a right angle here. So we know it has to be a right triangle. Now let's classify it based on the sides. All the sides are of different lengths, so that means it must be a scalene triangle. So this is a right scalene triangle. Number two, we see that all of our angles are acute. They're less than 90 degrees. And we see that none of our sides are the same. So that means that we're dealing with an acute scalene triangle. Okay. Next up, number 3, we have a 40-degree angle, 23-degree angle, and 17-degree angle. Well, this is an obtuse angle, so we know we're dealing with an obtuse triangle. And if you notice, all of the angle measures are different, which means all the side lengths are different. So that means we're dealing with an obtuse scalene triangle. Okay. Look at number 4. Number 4, we see we have a right angle here. So we automatically know it's at least a right triangle. And we see that none of the angles are congruent to one another. None of the sides are equal to one another. So we're dealing with a right scalene triangle in this one. Number 5, we see that we have our three sides are all the same. They're all equal to 16.7. And we see that our angles are all equal to 60 degrees. Well, the only triangle that has 3 equal angles and 3 equal sides is an equilateral triangle. And, you know, you may also see it referred to as an equiangular triangle, but, you know, equilateral is sufficient. Number 6, we see 2 tick marks here, 2 congruency marks here, and we see 2 angle marks here. So we have 2 congruent angles and 2 congruent sides. That means we're dealing with an isosceles triangle. But what type of isosceles triangle is it? Is it acute, right, or obtuse? Well, if we look at our angles, we can see that they are very clearly less than 90 degrees. So we're dealing with an acute isosceles triangle. So what I want you guys to do, I want you guys to try the next 6. Pause the video, name these, then come back and see if your names are correct. So let's look at number 7. Number 7, we have an obtuse angle, and we see that none of the angles or sides are congruent to the respective sides or angles. So that means that we're dealing with an obtuse scalene triangle. Number 8, we see 2 sides that are congruent, and we see 2 angles that are congruent. That means we're dealing with an isosceles triangle. So we see our angles here, these are acute, but this one is obtuse. So that means we're dealing with an obtuse isosceles triangle. Next up, number 9. Number 9, we see a right angle in our diagram. But we also see that we have two 45-degree angles and two sides that say 2.6. So we have two congruent angles and two congruent sides. So we're dealing with an isosceles, and it's a right angle. So we're dealing with a right isosceles triangle. Number 10, we see we have three sides all marked as congruent, three angles all marked as congruent. The only one that does that is an equilateral triangle. Number 11, we see two congruent tick marks, so that means that we have two sides that are congruent. We also have two angles that are congruent, so we're dealing with an isosceles triangle, and then this right angle here tells us we're dealing with a right isosceles triangle. Number 12, we see that none of our angles are congruent, none of our sides are congruent, and we see that we have an obtuse angle, so we're dealing with an obtuse scalene triangle. Okay, and that does it for this instructional video, guys. There is a practice worksheet posted on Google Classroom for you to try. It does have quite a few problems, but they should go fairly quick because most of them are just labeling or finding an angle using the triangle sum theorem. As always, guys, if you have any questions, please email me or join the Zoom sessions. If you have any concerns, you can do that as well. Thanks, guys, and I will see you in the next video.